All right. So, hello everyone. Today we are going to further build our framework, and this is going to be a very important session today. We've actually designed our arena, and arena is working fine. We are able to fetch the tensors blocks from the arena, and we've done this for every tensor that was already defined in our framework, right? So in case, if I want to show you something, that's how our main file looks like, right? We've done all the mandatory changes. We have initially we've created this tensor create method, which would just take the dimensions of the tensor, shape of the tensor, and it would just create a use malloc function, and then would define a tensor and populate it with some random data. Then we decided that this approach is not very suitable because it can create memory segmentation and all other issues. So we've defined our system in such a way that it should have a one contiguous block of memory, and on the fly it's just going to take some chunk of data without just populating it. It would be having some garbage data or some, if you are using calloc, all zeros, no initialized tensor, and then at the end what we'll do is we'll just initialize all the tensors and activations at once, right? So this was actually the idea. Now you might ask, if we are defining a tensor on a memory and we're not just populating it with some data, then how will the tensor look like? I mean, how if we want to backtrace the tensor, how can we? So we can do this by simply returning a pointer. For example, if I have 10 bytes of storage and I took initial 4 bytes, so the arena alloc method would return me this void pointer of the fourth byte, right? That's how I can keep track of all the tensors that I've defined already. So I'm gonna, each time I'm defining a tensor, and then I'm gonna add up the offset. Now, here comes the challenging part. So everything is working fine for now. Yesterday, if you watched my previous video, I just stumbled upon an error related to tensor memory, and it was like, I was using tensor free somewhere, and I was using free to remove some memory, which was early defined using arena alloc, which is not suited, because if you're using malloc, which I had initially, then you can use free to remove the memory that is being used. But if you're using your custom defined malloc, something like arena alloc, free won't work there, and that's why we're actually stumbling upon this error. So this was only one error. The rest of the framework was working just fine. If I go ahead and show you, where's my run file? So this is my run file, right? So I've actually linked arena there as well. If I run it, you can see, it's running the epochs successfully, right, with zero loss. And that's how it's just supposed to work, because loss won't be anything unless we have data inside the tensors, right? So that's what we're going to do now. So I think the idea is clear. What we're going to do is we're going to populate those tensors which are initially defined on the arena, and then we're going to run layer after layer forward and backward propagations and see where we actually stand, whether it's working or not. And if this does work, it's going to be a huge step ahead of our framework, because we have defined our own pool of memory, right? Later on in the coming videos, I'll discuss what actually is the benefit of defining this memory arena. So without any further delay, let's get right into it. So this is going to be a very important session, and let's see how it works. So, all right, focus mode on. Get branch. So we have arena. Let's define the branch first. Check out dash b, and this is going. I'm going to call it model for now. Right. So get branch. Okay. So we're at the model. Perfect. Okay, let me just quickly do one thing here first. All right, perfect. So we're at the branch model, and first of all, I'm going to create its header. So let's just define a header, model.h, and okay, so model h touch model.c, and having a file where its relevant methods are going to be defined, right? So vim_model.h and let's start writing code. So if not define model h, define it model h, and I always forget this end flag. And our methods are going to be first of all, we'll be initializing tensors, so it's going to be void tensor randomize. So we have two type of random tensors. One are floats and the other ones are integers. So for the token IDs, we're going to be using integer tensors, and for weights, we're going to be using float tensors, right? So let's just call it specifically random optimize tensor random weights, and it's going to take tensor pointer, yeah, and what it should do, it should take the size of this tensor, so size t, size, tensor size, and for tensor size we need to call what, tensor dot h here, and tensor size what, x. Okay, let's define a rand float here. Data I rand float, and yeah, that's it. And what is rand float? So let's just call it from config dot h, and inside config we have something called rand float. This is going to be float rand max, I guess. Yeah, this should work fine. Oh, somebody earlier told me in comment section that I should not quit the files in the Vim. So yeah, thank you so much for the advice. I'll take it from here onwards. I'll try to not actually quit the files. I'll try to, change the file inside one session or terminal, you can say. So it's one terminal, but one window, you can say. All right, so model.h, and here we have rand float. Perfect. And this should work fine. And let's just test it. Okay, we'll test it later. Let's just write all the functions first. Okay. All right, cool. So yeah. dot h. Okay. Um, mhm. Okay. Uh, tensor get. Uh-huh. Mhm. Okay. I need to modify this actually. T.C arena, and then we have tensor. can I print it like this? Tensor size isn't working. Let's just check the definition of tensor size. I think there might be some differences over here with malloc and arena lock. That's why it's not fetching the size correctly, but it should, I guess. Let's just check. Tensor C. Uh, Tensor shape. Can we change its definition? We can change. We can just literally count the number of items. And T shape. Okay. Lim T. And let's say we have instead of shape, tensor shape. Will it do something? Well, how about if we do something like this? Tensor create new is not working. And let's just see why not. Tensor create new dimension and shape. We're passing shape as a pointer. And this is going to be what? Shape 0. Say 2, and shape 1 is also 2. And check now. Boom. What is wrong here? Arena C. See, everything was working fine. Even just a static representation of array was also working fine. What is wrong? Okay. is wrong here? What the heck is wrong? I mean, I don't know. Okay, let's just check with Arena. This should work fine. This should work fine. I don't know what the heck is wrong here. Like, seriously. Oh, Arena is working. Exact same thing we were doing there, but that script is, for some reason, it's not working. Arena initiated. I mean, the script is exactly the same. Tensor size Z. This should work. Vim tensor C tensor size. This returns size. This returns an integer. So I think we should print this. Arena. We'll check that file later. We'll figure out why it's not working for some reason. So we are doing the exact same thing over here. Let's not waste our time, and we'll look into that script later why it was not working. All right. Funnel seed time. All right. So. Uh, Perfect. Let's just copy this code. And come over here. And remove this. And see if this works. Multiple definitions, that's right. Yeah. Now this one's working as well. So, okay. Let's see if this works. Oh, size undeclared. Why can't we get this size from config? Oh, man. Are you serious? Is it like arena size? Oh, now it's working. Okay. Let's delete this tensor, get the size of x, get the foundations right, and yeah, we're good to go. Fine. So we've actually defined a tensor. We have we've grabbed a chunk of its size from the contiguous array, the big block of array that we defined over here. And now let's go ahead and populate this as well. So uh, where is model.c? There it is. Perfect. Tensor randomize weights. It's gonna take tensor. Okay. Mm, okay. And where is model.h? Oh, I should not define it for you. It's just a prototype. Okay. Model.h and wow. Okay. First of all, let's check its shape before tensor shape. Tensor. Okay, fine. Super nice. We're able to get all the zeros inside our tensor. Not populated yet, so let's just populate tensor randomize. Is it like model.c? Okay, tensor randomize weights. X. Undefined reference to tensor randomize weights. Okay. Probably we haven't added this. Do we need arena? Do we need? Yes, we need arena. Model.c. We need this as well. Unknown type tensor. Huh? Dude. All right. Undeclared. Rand float undeclared. Okay. Rand float and apparently this looks fine. Have we defined it somewhere else? Yes, we have. Mhm. Uh, let's just delete at least these three. Math, standard lib, no. Float, rand, float, undeclared, first use, no. Yeah. So let's check the randomized tensor. Um, rand float. It's going to be float. Rand divided by. Okay. Still issues. This is a declaration of rand. Warning, this is declaration srand. Srand is a define. What is wrong here? Let's just check what's wrong here. Okay. Okay, so I think I'm using model.h here. I've defined the random float. Random float. Arena.c. Let's see if arena works. Okay, what next? Randomize weights. Okay. Size undefined. Implicit declaration fstrand. Okay, so still undefined. Rain float is still not working. What the heck is wrong? I mean, what the heck is wrong? Okay, so arena model tensor linked mats apparently seems fine. Okay. No alignments, no zeroing, no failures. This, but transformers, memory fast. Okay. Um. There you go. So I know it was a very small bug in the error because in C every file compiles differently, uh, or independently. So what I did actually, I was not adding these two files over here. Instead, I kept on adding in main. But like I said, it compiles each and every file independently, so that's why it was not working. So these two files were the important files, um, string lib and time. I've defined it twice, and yeah, so this is our the definition. So that's how we are going to actually populate our tensors. Uh, mm, Model.c. Yeah, this is our model file, and this is our arena.c. And what? That's it. So we are able to populate our tensors, and likewise we're going to do this for all others. So in model.c, um, I'm going to do this for just integer values as well. And well, I should not do this here. Yeah. So I think doing this in main is enough for now. Yeah, we are doing this in main. So we are calling arena as main for now. And what else? So if I check model.c, model.c has random tensor randomize as well, and what it does actually, instead of random float, um, it should not make them float. Oh well, wait a second. Let's just check. Uh, Tensor.c, and if I see what tensor create. Yeah, so this is actually tensor create and defines the size and just random integer. Okay, so in dimension, yeah, there it is. So rain mod 10. So, oh, man, rand mod 10 plus 1.0f to make it float. Uh, so arena, instead of age, just randomize it and see if we get something. Yeah, we do get something. But what was this error at the start? It wasn't error actually, it was warning. What sort of warning it was? So arena. Um, X data at I if count equals 5. Just give me 5 values. Break plus count. Yeah, tensor random, tensor size, tensor randomize, implicit expression tensor. Yeah. So the error is here in model.h because we haven't actually. Now things are simple because we have actually done the hard part, and that is it. So I'll see you in the next video because this video has already become too long, and unfortunately we stuck upon a very simple error. And yeah, things are simple now. We've set the foundation for funnel seed time. Sorry, we've set the foundation for our um, just populating our tensors all at once, and then We'll be working in next videos for multi-head attention and V4 neural networks and layer nodes as well. So see you then. Take care.